In this lecture, we are going to discuss about the three-phase inverter 120-degree conduction mode. In previous lecture, I had discussed about the three-phase inverter having a 180-degree conduction mode where each thyristor operates for a 180-degree angle. However, in this case, since this is a three-phase inverter having a 120-degree conduction mode, so in this case, each thyristor will operate for a 120-degree conduction mode. That's why it is called the three-phase inverter having a 120-degree conduction mode. Let us look about the configuration of this three-phase inverter. That we have here three legs of the thyristor. So see, this is one leg, this is second leg, and this is third leg. So in the first leg, we are having a two thyristor, thyristor T1 and thyristor T4. In second leg, we have a thyristor T3 and thyristor T3. And in third leg, we have a thyristor T5 and thyristor T2. It should be remembered that all the thyristors are connected with anti-parallel diode. Just see, this thyristor is connected with this anti-parallel diode and this thyristor is connected with this anti-parallel diode. Same way, all diodes are connected in anti-parallel. And this is the supply voltage source Vs, that is plus minus polarity DC supply, which has been given to this three-phase inverter. And same time we have a star connected load, that is three-phase star connected load R, Y and B. Each phase is having impedance Z. This is impedance Z, Z and Z, and connected with a star neutral point, that is N. So if you see in this diagram, this R phase is connected in between the thyristor T1 and T4. Then Y phase is connected in between the thyristor T3 and T6. And B phase is connected in between the thyristor T5 and T2. That is how the configuration is made for the three-phase inverter having a 120-degree conduction mode. Now we have to think about that how this system will operate. This three-phase system will operate. That is, how to we have to see that how this three-phase system will operate. So we have to give the firing sequences to each thyristor. So how to give the firing sequences to each thyristor, that we have designed here. Let us see, we have made this table where the sequences given to the each thyristor, that is firing sequences given to the each thyristor, has been shown here. Let us first discuss about the thyristor T1. So we see here the thyristor T1 is giving a firing sequence from an angle 0 degree to 120 degree. Why 120 degree? Because we know that in this case each thyristor will operate for a 120 degree conduction mode. So that's why T1 is given a firing pulse from 0 degree angle to 120 degree. Then comes the T4. So, but after T1, once T1 has completed the 120 degree conduction mode, then for 60 degree, this thyristor will not conduct. It means in the branch leg first, that is there are two thyristors T1 and T4. So in this case, neither T1 will conduct nor T4 will conduct. So we will give the off period for the 60 degree duration. To see the off period, it means the shaded color which has been shown here, this is the shaded part which has been shown here, that in this interval there will not be any conduction from thyristor T1 or T4. Then after that, between angle 180 degree to 300 degree, we will give a firing sequence to thyristor T4. This is the T4. So T4 is placed here. So it means T4 will operate from an angle of 180 degree to 300 degree. That is total duration of 120 degree. Then after that again we will give the 60 degree interval, that is not non-operation of the thyristor. It means between this 300 to 360 degree, that is the interval of 60 degree angle, there will not be conduction from thyristor T1 or T4. So this is the first row which I have completed. Now comes to the second leg. So in second leg, we have seen in the figure that there are two thyristors T3 and T6. So how T3 and T6 is given firing sequence? as we know that each thyristor in this case will operate for the 120 degree conduction mode, and each leg thyristor will operate after a delay angle of 120 degree, that is the phase difference. So it means first leg has completed the conduction angle. Now second leg will start after delay of 120 degree angle. That's why T3 starts conducting from an angle of 120 degree to 240 degree angle. So this is the T3 firing sequence which has been given here. Then after that we'll have a 60 degree off interval. It means neither T3 nor T6 will be conducting in this interval. And then we'll have a T6. So we'll have to give the firing sequence of T6. So here only from 300 to 360 degree, only 60 degree firing sequence is available for the T6 thyristor. So next 60 degree will be given from this duration, that is between 0 degree to 60 degree. So this is the T6 duration. It means 60 degree from here and 60 degree from here. If you add both, we'll get the 120 degree duration. It means for thyristor T6 also we have completed the 120 degree conduction mode. Then we will give the off period for the 60 degree interval. So this is the 60 degree interval. Between 60 degree to 120 degree we have given a off period where neither T3 nor T6 will be conducting. This is how the firing sequence has been made for the second leg. Now we'll see the third leg. So in third leg there are two thyristors, thyristor T5 and thyristor T2. So in this case the thyristor T5 will start operating after a phase delay of 240 degree. So this is, see here, after phase delay of 240 degree, a firing sequence is given to thyristor T5, and this T5 will operate for 120 degree. It means from 240 degree to 360 degree it has completed 120 degree. And after that, since we have to give the off period, off interval, so this is the off interval from 0 degree to 60 degree when neither T2 nor T5 are operating. Then after that this T2 will be operating for 120 degree. So from 60 degree to 180 degree this thyristor T2 is operating, and after that again we will give a off interval for a 60 degree duration. So from 180 degree to 240 degree we have given a off interval in which neither T2 nor T5 are operating. So what we see in the case of firing sequence is that the shaded portion with the red color, that is this one, this one, this one, and this one, this one, this one, we have shown with the red color the shaded portion where the thyristors in respective of their rows they are not conducting. So that's why we have shown with shaded color where there is no thyristor conduction interval. Now we have to see that in first case, when, let us see, first interval when it starts from a 0 to 60 degree angle. So we start from 0 to 60 degree angle. Which thyristor will be conducting? It means in the all cases, all the degree of interval, there will be only two thyristors will be conducting. So we'll see between 0 degree to 60 degree, thyristor T1 and thyristor T6, they both are conducting, and since this is a non-operating interval. So look at this figure. Where is T1? This is the T1 and this is the T6. It means T1 is connected to the battery positive and T6 is connected to the battery negative, and this T1 is connected with R phase and T6 is connected with Y phase. So equivalent circuit diagram has been drawn here. In the first case it has been shown here. This is the Vs and supply voltage, and this is the R phase and this is the Y phase, and in between there is impedance Z, and here this is also impedance Z, and in between the both impedance this is a neutral point which has been shown here also. This is the neutral point. So we have to find out the voltages VRN, that is phase to neutral voltage, and VYN, that is phase to neutral voltage. So if we want to calculate the VRN, so we will apply the voltage divider rule. So what is the voltage divider rule? It means this is supply voltage Vs into Z upon Z plus Z upon Z plus Z. So if we solve this, it will comes out to be Vs by 2. So this is the voltage between R phase neutral, that is VRN. It comes out to be Vs by 2. Now we will calculate the VYN, that is phase Y to neutral voltage. So in similar way we will calculate VY1, but in this case Y phase is connected towards the negative terminal of the battery. So we will write here minus Vs into Z upon Z plus Z upon Z plus Z, having a voltage divider rule. So if we solve this, it comes out to be minus Vs by 2. It means the voltage between Y phase neutral phase, that is VYN, is equals to minus Vs by 2. And in this equivalent circuit diagram, as we know that there is no B phase is connected in this circuit, so we will take voltage between B phase to neutral, that is 0. That's why we have written here VBN equals to 0. Now we'll move to the next interval. That is, next interval means from 60 degree to 120 degree interval. So let us see in this interval what are those thyristors which are operating in between 60 degree to 120 degree. Just see from vertical, this is T1 and this is T2. This is T1 and this is T2. Since there is no thyristor conduction, only T1 and T2 they are operating. That's why we have written here T1 and T2. And look in this circuit diagram, what is T1? T1 is connected with positive battery terminal and with R phase, and T2 is connected with negative terminal of the battery and with blue phase, that is B phase. So equivalent circuit has been drawn here, that is the Vs is the supply voltage, and from here this is the R phase with some impedance goes to neutral, and from negative side B phase is connected to negative, so from negative side B phase impedance Z and neutral. This is how equivalent circuit has been drawn here. Now once again we have to find out the phase voltages, that is VRN and VBN. So how to find out the VRN? That is in similar way as we have derived in the first step, that is Vs supply voltage into Z upon Z plus Z upon Z plus Z. If you solve this, this comes out to be Vs by 2. Similarly, we will find out the VBN. So what is VBN? Since B phase is connected towards the negative side, this is the negative side. So we will write here VBN equals to minus supply voltage Vs dot impedance Z upon Z plus Z upon Z plus Z. So if you solve this, it comes out to be minus Vs by 2. And we know that there is no Y phase is in picture of in this figure. There is no Y phase connected anywhere in this circuit diagram. So we will write here voltage, that is VYN equals to 0. So far we have calculated these phase voltages between interval 0 degree to 60 degree and between 60 degree to 120 degree. Now we will move towards the 120 degree to 180 degree. So let us see in 120 degree to 180 degree what are the thyristors those who are operating, that is thyristor T3 and T2. What are thyristor operating? That is thyristor T3 and T2. So where is T3? T3 is connected from positive side, see from positive side, and is connected with Y phase, and T2 is connected from the negative side of the terminal and it is connected with the B phase. So we have a impedance between the Y phase and B phase. So that is the equivalent circuit has been drawn in the next case. That is, see here, between the Y phase and B phase we have drawn the circuit where the thyristor T2 and T3 are conducting. So this is the supply voltage, this is the Y phase, impedance Z and neutral, then again impedance Z and B phase. So we have to find out the voltages VYN here, VYN and VBN. So similarly in previous case as we derived, here also this is supply voltage Vs into Z upon Z plus Z upon Z plus Z. This, if you solve this, this comes out to be Vs by 2. This comes out to be Vs by 2. Now in next case, we will find out the VBN. So what is VBN? It means in VBN, since B phase is connected toward the negative side, so we will write here minus Vs supply voltage into this impedance Z upon Z plus Z upon Z plus Z. So if we solve this, this value comes out to be minus Vs by 2. And since in this circuit diagram there is no R phase connected to anywhere, so we will write here VRN equals to 0. It means we have again find out VYN, VBN and VRN equals to 0. This is the third interval. Now we will move towards the fourth interval. So in fourth interval, we have a conduction between 180 degree to 240 degree, where thyristor T3 and T4 are conducting. So just see, thyristor between 140 degree to 240 degree, thyristor T3 and T4 are conducting. So where is T3? T3 is connected from positive side and to this Y phase, and this is correct. Then T4 is connected with negative side and between R phase. So this is, now we will draw the equivalent circuits. So what is the equivalent circuits? Just see here. In 4 case, we have a T3 to T4 where the Y phase and R phase are connected, and we have a supply voltage Vs. So R phase is connected to the negative side and Y phase is connected to the positive side, and we have a respective impedances. So let us find out the voltage VYN. What is VIN? It means supply voltage Vs into impedance Z upon impedance Z plus Z upon impedance Z plus Z. So if we solve this, this value comes out to be Vs by 2. Now what is VRN? Since R is connected towards negative side, so we will write here minus Vs. So minus Vs into this impedance Z upon impedance Z plus Z. So impedance Z plus Z. This value, if you solve it, it comes out to be minus Vs by 2. Now see in this case, when we have to find out the voltage VBN. So B phase is not connected anywhere in the circuit. So we will write here voltage VBN equals to 0. Now we will move to the next interval. That is interval between 240 degree to 300, where T4 and T5 are conducting. So let's see between an angle of T240 to 300. So what is angle of 240 to 300? This is 240 to 300 where thyristor T4 and T5 are conducting. So T4 is connected from negative side with the R phase, and T5 is connected with positive terminal of the battery with B phase. It means R or B phase are connected. So we'll draw the equivalent diagram R and B phase. Just see here, this is the thyristor T4 and T5, and this is the positive supply. This is the B phase and this is the R phase. In between we have a impedances. So let us find out the voltage VBN. What is VBN? It means positive voltage Vs into impedance Z upon Z plus Z upon Z plus Z. So this value, if you solve it, it comes out to be Vs by 2. Now next case, we will find out the VRN. So since R is connected toward the negative side, so we will write here VRN equals to minus Vs into this impedance Z upon Z plus Z upon Z plus Z. If you solve this, this value comes out to be minus Vs by 2. So VRN is minus Vs by 2. And since no Y phase is connected in the circuit, so we will write here VYN equals to 0. It means 3 voltages VBN, VRN and VY1 we have calculated. Now let us move to the last step, that is the degree interval between 300 to 360 degree, where thyristor T6 and T5 are conducting. So just see in this diagram, in the last interval, in the interval 300 and 360 degree, thyristor T5 and T6 are conducting. So Where is T5? Just see. In T5, this T5 is connected from positive side and with the B phase, and T6 is connected from the negative side and with Y phase. It means the equivalent impedance is between the B phase and Y phase. So thus see, where is the equivalent circuit? This is the equivalent circuit between B phase and Y phase, and this is the supply voltage Vs, and these are the impedances. So we have to find out the voltage VBN, that is VBN. So what is VBN? It means, again we will apply the voltage divider rule as we are repeating in the previous steps, that is supply voltage Vs into Z upon Z plus Z upon Z plus Z. So if we solve it, this value comes out to be Vs by 2. Now we will find out the voltage VYN. So what is VIN? Y is connected from towards the negative terminal of the battery. So we will write here minus Vs into impedance Z upon Z plus Z upon Z plus Z. If you solve this, this value comes out to be minus Vs by 2. It means now we will find out the VRN, and we see that in this case there is no R phase connected to in this circuit. So we will write here VRN equals to 0. So now we have seen that we have calculated all the phase voltages, that is phase to neutral voltages between angle of 0 degree to 360 degree. So now we will plot the waveform for these voltages which we have calculated so far for the 6 intervals. So how we will plot the voltage waveform? Just let us see. So in previous steps we have calculated the various phase voltages. For simplicity we have written all the values here, that is VRN equals to Vs by 2, 0, minus Vs by 2, minus Vs by 2 and 0. This is the 6th interval, 1, 2, 3, 4, 5, 6, that is between 0 degree to 360 degree. Same way we have calculated in previous steps, that is voltage VYN. So we have written for simplicity this VI1 is equal to minus Vs by 2, 0, Vs by 2, Vs by 2, 0 and minus Vs by 2. And again we have written VBN. What is VBN? VBN is, in first interval it is 0, then minus Vs by 2, then minus Vs by 2, then 0, then Vs by 2 and then again Vs by 2. So these are the phase voltages, that is voltage between phase to neutral, which I have obtained here. Now we will find out the line to line voltage, that is, if we see here we have written here VRY, that is the line R, voltage between the line R and line Y, that's why it is called the VRY. So if you want to calculate this value, so we can write here voltage VRN minus voltage VYN. So it is written here VRN minus VY1. So this is VRN, this is VY1. If we subtract this minus this, so we will find the equivalent line to line voltage. So let us see in first step, this is Vs by 2 and this is minus Vs by 2. So Vs by 2 minus Vs by 2, that will become plus. So Vs by 2 plus Vs by 2. So this will comes out to be Vs. That's why it is written here, this is Vs. Now let us see in next step, Vs by 2 minus 0. So this will become a Vs by 2. So it is written here Vs by 2. For next case, let us see 0 minus Vs by 2. So it will be equal to minus Vs by 2. It is written here minus Vs by 2. So similarly, we can find out the in next step also, that is minus Vs by 2 and 0. Same way we can find out the voltage VYB, that is the line to line voltage between Y phase to B phase. So how to calculate? That is, we can calculate voltage VYN minus voltage VBN. VYN minus voltage VBN. So let us see, in first interval we have minus Vs by 2 and minus 0. So it will become minus Vs by 2. That's why it is written here minus Vs by 2. And similarly we can calculate 0 minus Vs by 2. This means 0 minus minus है तो ये plus हो जाएगा, this will become plus. So 0 minus minus plus, it means Vs by 2. So this is Vs by 2. So similarly we can calculate the voltages in the next step, that is Vs by 2 minus Vs by 2 and minus Vs. Let us see in the next case, that is when we have voltage VBR. How to find out the VBR? That is, we can find out the voltage VBN minus voltage VRN. So VBN minus voltage VRN. So in first interval, just see 0 minus Vs by 2, it will become minus Vs by 2. So similarly, it will is minus Vs by 2 and minus Vs by 2. So it will become a minus Vs. So it is written here minus Vs. So similarly, we can find out the next step, that is minus Vs by 2, Vs by 2, Vs and Vs by 2. So these are the various line voltages which you have calculated, and these are the phase voltages which you have calculated. Now we have to put these voltages into the shape of waveform. So how? First we have plotted the voltage VRN. So what is VRN? This is the phase to phase voltage. So in first step we have a Vs by 2. So this is the Vs by 2. Then again for next 60 degree interval we have Vs by 2. So we have a Vs by 2. Then for next 60 degree we have 0 voltage. We have 0 voltage. Then for next 60 degree we have minus Vs by 2. So we have minus Vs by 2. Again for next 60 degree we have minus Vs by 2. And then for next 60 degree we have 0. So this is the 0. So we have plotted this waveform for the phase to neutral voltage, that is VRN. This is VRN. Similarly, we can find out the voltage VYN. So this is the voltage VYN. So what is in first step? In first step it is minus Vs by 2. So we have started from here minus Vs by 2. Then for the next 60 degree it will be 0. So for next 60 degree it will be 0. Then for next 60 degree it is Vs by 2. So for next 60 degree it is Vs by 2. Then again for next 60 degree it is Vs by 2. It is Vs by 2. Then it is 0. It is 0 for 60 degree. And then minus Vs by 2. And then it is minus Vs by 2 for next 60 degree. So this is the waveform for the phase neutral voltage, that is VYN. Now we have plotted here the phase to neutral voltage between VBN. So what is VBN? VBN shown is here. So in first step we have a 0 voltage. So we have shown 0 voltage for 60 degree interval. Then we have a minus Vs by 2. So we have shown minus Vs by 2 for 60 degree interval. Then again we have minus Vs by 2. So again minus Vs by 2 for next 60 degree interval. And then we have a 0 voltage. So we have a 0 voltage for 60 degree interval. Then Vs by 2. Then it is Vs by 2. And again then Vs by 2. And again this Vs by 2. So this is the voltage waveform for the phase to neutral voltage, that is VBN. So now we can plot the line to line voltage also. We have here 3 line to line voltage, that is VRY, VYB and VBR. So we will plot only for the line to line voltage between VRY, and as we will plot the VRY, similarly we can plot the VYB and VBR also. So how we are going to plot the VRY? That in the first case we have a supply voltage Vs. This is supply voltage Vs for 60 degree interval. Then we have a Vs by 2. So we have a Vs by 2 for 60 degree interval. Then we have a minus Vs by 2. So then we have a minus Vs by 2 for 60 degree interval. Then we have a minus Vs. So we have a minus Vs for next 60 degree interval. Then we have a minus Vs by 2. So we have a minus Vs by 2 for 60 degree interval. And then we have a 0. So finally we have a 0 for next 60 degree interval. So this is how we have plotted the line to line voltage, that is between R phase to Y phase, that is VRY. This is the waveform for the line to line voltage between VRY. So similar process it can be repeated for the next line to line voltage, that is VYB and VBR also. So this was the overall operation and control of the 3-phase inverter having a 120 degree conduction mode. These are the various waveforms which I have drawn here. If you like this video, then please subscribe this channel for more videos.